Let's start this video by taking a look at the effect the device we're about to take to bits produces. And it's an old disco effect, a kaleidoscope effect that is based on I think it's a 250 watt 24 volt halogen lamp. Not sure, I can smell it right now because it's burning dust. And it's pointing through a rotating glass disc with bits of loose dichroic inside it and oil by the look of it to actually slow the movement and lubricate it and stop it scratching perhaps. And that is then being fired through a triangular tunnel of mirrors, and one of those mirrors is rocking backwards and forwards on a cam to create the fanning effect. Not sure if I like the fanning effect as much as just the general dropping dichroic glass and the little bubbles in there. It's a very good effect. It's a really nice effect. Let's open it up and see what makes it tick. I'm filming in a different location at the moment, so it will sound probably quite boxy and boomy, it usually does here. That's just what we've got at the moment, so my apologies for that. I have put a sticky plaster over the current winter wounds from work, just because, well, it's to protect the squeamish. So let's take a look inside this. I wasn't actually going to open this tonight, but once I tried it, I just couldn't resist. I had to get this back open and see what's inside it. So what we've got in here, we've got the transformer is the biggest, heaviest component. This thing incidentally weighs 10 kilograms. That is approximately 22 pounds. It's a heavy unit, and that's largely because it's got a really massive transformer in it for this halogen lamp here. This little, let's pop this out in fact. Will it come out easily? Yes, it will. This lamp here, which is, I wonder what the wattage actually is. It's cracked at the base. It is the original 24 volt 250 watt lamp. Okay, so we've got the dichroic lamp at the back. I'll just put this down here at the moment. Now the transformer has a red wire, a black wire and a yellow wire. The black is the common wire. Hold on, am I right in saying that? No, it's not. The yellow is the common wire. And if you use the red wire, it's for 120 volts. If you use the black wire, it's for 240 volts. It's just basically 2 taps. And it's worth mentioning a little story about one of these transformers on a fairground ride, which it's a really unpleasant story. It involves a maintenance guy who, the ride car had a 24 volt light in it and a 120 volt feed going into it. And the transformer failed, so he got a new transformer which had a similar arrangement to this. And he saw the windings marked, say for instance, yellow for the neutral and black for the, in his case it would be the red one, was for the 120 volts. But he didn't know that when you connect them up like that, you should tape up the other wire. You should secure it and insulate it because it steps voltage up. It acts like an auto transformer. So he didn't know that, and that other wire, which he left loose, came live at 240 volts when the ride was in use. And what actually happened is it found a ground path. It touched the metalwork and it spot welded itself on, making that whole car on the ride live. And people were reporting that they were getting electric shocks off it. So he went to check it out, and apparently there wasn't good earth continuity to the rest of the ride because he was standing on the checker plate or kneeling on the checker plate. It was raining. He went to open the car to actually work on the electrics inside and was unfortunately electrocuted right there and then. So it's worth mentioning that when you've got a transformer with these multiple windings, make sure the other one is taped up because it will effectively become live at whatever voltage. In our case, the red one here, because this is connected to 240 volts, the sender tap would become live at 120 volts with respect to ground effectively. So just make sure that when you've got a transformer with multiple taps and the wires coming out, just make sure they're all accounted for and insulated. So we've got 240 volts coming in here. It comes straight in, and the first thing that happens is the live wire goes to this fuse here. It then goes down to this terminal block. We've got a 12 volt fan here, and it's got its own transformer, which is quite unusual. A little transformer tucked under here with auxiliary windings. Are they taped up or are they just, I think they're just taped out of the way. Hold on, I'll just tilt this so you can see it. That's better. There's a little transformer down there, and it's putting out, I would say 12 volts. I don't know if it will be 12 volts or it might be lower because the voltage will increase when it's rectified and smoothed, which is what happens in this circuit board here. This is a full bridge rectifier based on discrete diodes and a capacitor, and that then provides the power supply to this lamp. This metal plate is to stop light shining out the back of the disco light, because in disco's jet black area, that is very visible, so there's lots of shrouding. Likewise, the lamp housing here had a little shroud over the top as well. The mains is coming down to this terminal block. It goes to that transformer, which then feeds the fan. It then also has 3 wires coming out here. One feeds the main lamp transformer, and the other 2 sets of wires go to 2 separate motors. This motor here has a cam in the front that just rocks that mirror backwards and forwards, and I'm not sure. I think it's just tape. It is just tape. That's all that's holding that together. That's a bit shitty, isn't it? And to stop light firing through the optical system here, because there's a port to allow for that, it's got a little metal flap stuck on the side of the mirrors here, that little mirror assembly. The other motor has a fairly heavy geared motor. I don't know if you're going to see that. A big cogwheel down there, which then makes contact with the cogwheel on the dichroic wheel, which is covered in oil. I'm not sure if that's just lubricant oil or if it's actually leaked. And the light shines through that, and then through this manky lens, which isn't going to help things either. This collimating lens here goes through the mirror triangle, the Toblerone of mirrors, and finally goes out the end through the focusing lens, which is just falling to bits. And it's quite a thin lens. It's not that thick at all. And it's adjustable. You can screw it in and out normally, except not now, because this is just like falling to bits. It really looks like it's been dropped. It doesn't look like age fatigue. That's annoying. But that screws in to actually focus through the triangular mirror assembly onto the dichroic wheel. So what I can do now, this top bar is holding everything together, and these are screwed down to the ground. So I'm going to actually remove this whole mechanism, and we'll take a close look at it. I am so tempted to remove this and try and fit an LED in it, but I can't do that here. And I'd have to ship this back over to Alemania because I'm currently back in Glasgow. So give me a moment. I'm going to remove this and then we'll take a closer look at it. So a few more bits and a lot more oil later, it really is. It seems to be coming from the dichroics. Here's the first section. It's the lamp housing, and it's a simple, takes a standard sort of MR16 style lamp, and that simply slides down against that sort of rough front plate with this spring at the back, and all it does is it holds in by friction. It's a very simple lamp holder. It makes it very easy to slot new lamps in and take them out, and holds them in a very accurate position. So that's the lamp holder. The lamp holder then shines through the dichroic disc here, and the dichroic disc is rotated by this motor, which just is going straight onto the dichroic outer cogwheel. It is just a custom machine component. On the other side is this rather neat metal frame that they've used, which they've folded up in such a way that the collimating lens here sits in there, and by folding these tabs up and then the ends of them down, it's locked that in position. And that is the motor that's driving that. It's 10 to 12 RPM, which is driving that. What's the other motor? The other motor is 4 to 5 RPM. Now the 10 to 12, that means at 60 Hertz it's going to be 12 RPM, and at 50 Hertz it's going to be 10 RPM, because these are synchronous motors. And likewise, at 60 Hertz it's going to be the 5 RPM, 50 Hertz it's going to be 4 RPM. So I'll take that apart further, but initially I'm going to show you the mirror assembly, which is a bit tacky, as it really is just held together by tape in there to allow that sort of rocking hinge effect. I suppose plastic hinge really. But the motor rotates this cam, which then pushes this backwards and forwards, and that rocks the mirror assembly. And if we take a look down the mirror, let's see if I can do this. I don't know if this is going to work. Let's bring the mirror assembly up to the camera. Is that going to work? That is kind of going to work. You're going to see that that's the kaleidoscope effect that you get when you look down the mirror. That's how kids' kaleidoscopes works. It's basically a triangle of mirrors, and it creates that sort of multiple reflected image effect. So this is the interesting bit. I'm going to have to get down here and get into this. So I'm going to get some more use out of this very nice Wera screwdriver that was gifted to me at the Glasgow meet. So it's been used a lot at the Royal Edinburgh Military Tattoo. It's a very nice screwdriver. I didn't ever twig, I suppose ultimately, it's the fact that everybody copies these handles. I don't know whose is the original, but I didn't realise that Wera or Wera are actually such a high quality brand. It's a very good screwdriver. Let's lock that and take this apart. So I'm going to try taking this side off initially. Not sure if this is going to work. I'm suddenly realising that I should actually have had, no, actually, no, let's not. Let's take this off. It does seem a more sensible option. And that should release the, well, it's going to release the shmoo, unfortunately, because this thing is just absolutely dripping with oil. I'm thinking that if they've used oil as the liquid to slow the dichroic movement, it's possible that that's leaked, because ultimately you can't really contain that with the thermal expansion and contraction of the air bubbles that you're going to get inside. And that has probably meant that they can't really 100% seal that either. Is this going to come out? Yes, it is. Yes. I think that wheel might... One of these sides has the bubbles. I think the other side might actually be dry, but there's the dichroic glass on both sides. It's 2 layers. Is it more than 2 layers? And I'm guessing there are intermediate layers of glass. There's something gooey in the front of that. That might be dried oil. This thing, the lens in here, this really needed taking to bits to give it a proper clean. Ah, it really is just covered in oil. I don't know if that's purely lubrication oil that's just gradually spread. It's getting everywhere, actually. It's very schmoozy. So this is basically just a captive cogwheel. And they have put the glass in, they've tried to silicon, but you can imagine that if they try to silicon that, then if there's any trace of oil at all, the silicon is not going to seal there. It's going to actually let it weep out. I'm trying to see if there is any. I've got skid marks here where the oil on the outside is burnt and it's actually sort of hardened onto that. That's a bit of a shame. There definitely is oil in there though, because, hold on, I could see some oil moving about. I could see lots of little bubbles as it's all the glass slipped, and it certainly was an effect. You could see the bits dropping, but they're just absolutely staying put at the moment. Although having said that, as with oil, most oil wheels, when it heats it up, the oil gets more lower viscosity and it tends to slide about better. I do see in this layer that I can see a sort of wick round the edge of these glasses, so that it's not filled with oil in here. It is really just they're sliding out. Well, that's because the oil is all over my fingers apparently. Ugh. So it makes me wonder, it would be quite nice to see a new version of this created. Even something simple like, instead of the dichroics falling apart, because it's going to be operated at lower temperature, you could almost just create a sort of printed mosaic pattern on a wheel and rotate it if you had an LED source. And then, yeah, and the LED could also be, if you're using maybe a 3 watt or a higher LED and firing it centrally down the middle of that, it would be a kind of an efficient light source. I'd want to make the glass, the mirror sort of core that it goes down, the triangular core, I'd want to make that bigger, but I don't know if that actually is advantageous. This is, I mean, it's nicely made. It looks like the classic rotating, well, gobo rotator effect, but with this sort of, it's almost like gobo rotator meets oil wheel, but with dichroic glass inside. It's very attractive, this bit in its own right. It's so colourful. Dichroic glass, I should mention. Dichroic glass is used in the theatre and entertainment industry because it's got a very specific characteristic. It's extremely highly temperature resistant and produces very pure colours. It's basically glass with a vapor deposition of metal on it that is literally 1 wavelength of light thick. And that creates the amazing effect that you get a piece of glass that reflects all other wavelengths except the one that you want, and that passes straight through. So if you get, say, blue glass that you want blue light to shine through, it looks blue when you shine light through it, but the reflection, it actually looks like an orange mirror because all the other wavelengths are being bounced back. So this is very nice. It's a shame that it has succumbed to, well, oil leakage. I'm guessing it is just that thing. They've tried to fill that and then with oil and then they've sealed it with silicon. That's just never going to work, particularly with the thermal expansion contraction. But yeah, it's a visually nice effect. It's a really nice effect. I've never seen it since. I don't know if MD makes a kaleidoscope projector now. It would be interesting to see, if if it's not made anymore, if the Chinese manufacturers would take up take the challenge and produce something like that with the dichroics and an LED source and collimating optics, because that would be really, really nice, as you saw from that effect. So let's finish this video with another look at the effect and see how it looks, because it is a really smart effect.